All right. Welcome to another nanoCHAT. And these are little chances to reflect critically on the kinds of things that we do in the classroom. And today, in fact, how we reflect on how we teach students on how to do research. And so today's conversation, my name is Hillary Epley. I'm at DePauw University, and I'm going to be the facilitator today. And we're going to be talking about how we get new research students started on our research projects. So first of all, I'd like to introduce all of our participants today. And like I said, my name is Hillary Epley, and I'm at DePauw University.
Hello, I'm John Miecznikowski. I'm at Fairfield University. I'm a synthetic and organic chemist. I make a lot of insert complexes with sulfur, nitrogen, sulfur donor atoms, and we characterize these complexes and screen them for activity for reduction reactions and also electrocatalysis.
I'm Matt Kranzwick. I'm at Colorado State University, Pueblo. By training, I'm a spectroscopist, but I'm trying to be a synthetic chemist with my students. So we learn along the way as we do our research.
My name is Tulay Atesin. I'm at the University of Texas, Rio Grande Valley. We mostly do computational organometallic catalysis.
And I'm Ryan Richards from the Colorado School of Mines, and then also at the National Renewable Energy Lab. In my group, we do synthetic and organic chemistry of nanostructured materials.
Yeah, and I actually forgot to mention, I also do synthetic inorganic chemistry, essentially coordination chemistry in non-traditional solvents. So I'm going to start today, and I frequently have a lot of younger students in my lab who are starting out doing research for the first time. And one of the things that I like to do with them before we actually start in the lab is start talking about how you go about picking apart an experimental section of a previous paper that either we have written or that other people in a related field have written. And frequently what I'll do is I'll assign a particular paper for all of the students who are starting to look over, and I have them pick apart the experimental section for things like, for instance, I have them look at, where can you buy, what chemicals do you need to actually carry out this reaction? Can you buy these chemicals? I ask them questions like, how did the authors characterize these materials? Like, what kinds of methods did they use? What kinds of special conditions or equipment do they need to carry out this synthesis? And when I find when I'm introducing this to students for the first time, a lot of times they miss things like, oh, it was done under nitrogen, or the solvents were distilled, or things like that. And we get at those, how do you look for those kinds of things in an experimental section? I also have them sort of, it seems really basic, but trying to get them to like write a reaction with the correct coefficients in terms of how the things are combining and where to look for that in a paper. I find like by doing that, it helps us get started, and it helps them. One of the first things that we do in the lab is reproducing syntheses that somebody else has done, and that helps prepare them for how am I going to take this thing that's in a paper and turn it into an actual reaction on the benchtop.
So I work with a lot of first and second year students, at least to start off in my research lab. And I always like to introduce them to the community. So show them a few key literature articles so they can read them, just to get some background in the area. I like to have my students make a lot of starting materials, so all the ligand precursors they're going to be working with, so they can see how they were prepared. By doing so, they really get to set up reactions and learn how that works. They learn how to purify their products, characterize their products using oftentimes NMR spectroscopy. and just to get more familiarity with the instrumentation and the software on these instruments as well. Along the way, they build a lot of confidence along the way because don't have much experience in setting up these reactions in other courses, so this is all new for them as well. And then eventually we metallate and we grow crystals, okay? And then we run from there. And so they learn a lot in the process, and they really mature along the way as well.
Does anybody have, oh, go ahead.
No, go ahead, Hillary.
I was going to say, when you are introducing the students, are there particular methods that are that you find easier to start with in terms of, or do you jump them into, exactly, do you ease them into things, or are they doing things that are pretty challenging to start?
Usually I ease them into things. They're pretty straightforward reactions, but they start from the beginning and they learn how the ligand precursors are made right from the beginning, from the first step. So it's a multi-step synthesis and they start from the beginning.
Matt, did you have?
Yeah, John, I was just going to ask you, when you introduce literature, and Hillary also, to the students, do you kind of walk them through the whole thing? For me, it's a different experience maybe. Hillary, you talked about pulling apart the experimental section, but John, when you introduce literature, what type of understanding are you looking for from your first and second year students, if any?
Just to get the big picture,
Okay.
best as they can. They won't understand all the chemistry in there, just because they're so young in their scientific careers. But just to get the big picture, and they can see how some of this is applied later on.
I try to make sure that I emphasize they're not going to know all the words, and nor do they need to understand the whole paper to begin with. And one of the things I like to do is pick 5 words you don't know and find out the definition to one of them. And then we have a kind of an organic conversation about what do these words mean? Is this a word that really is important for your understanding of the paper? Or is this some like crystallographic thing that's kind of down in the weeds that you don't really need at this stage? And I find it can help direct them to the parts of the paper that are most important. I do like to have them try to summarize the paper, like summarize what they're trying to do, what the authors are trying to do, because I think that's a valuable thing to be able to get right from the beginning, but maybe not understand all the spectroscopy or all, the other kinds of things.
So I guess I kind of have a similar approach or hybrid approach. I do meet with the students, give them kind of the overview of the project, give them some literature, tell them you don't have to understand anything. I just want you to have this for now. And we revisit that literature throughout the project as they start to build understanding of what we're doing. But the students, for me, since they're typically first or second year students, like John, it's trial by fire. So I take them in to the lab and I say, we're going to set it up. I'm going to show you how to run the reaction, how to do the workup, or collect data on an instrument. And then I let them, when they feel comfortable, I try not to push them too hard, but when they feel comfortable, I start to say, okay, I'm going to let you do it today. I'm right here. I'm your buddy. We're going to walk through this together, but so that they can take ownership of that step. And it's always the reaction we've already run, maybe at a different scale or something like that. But that's how I do research. I don't know if it's the correct way to do research with our students, but it seems to work. So we do all right.
Yeah, I think a lot depends on how challenging the skills are that you need to do things. In terms of some of the things that I'm doing are things that they could probably do based on what they have from their intro classes, but some of the things are much more complicated and they need much, sort of more targeted training on those kinds of things. One thing I'm curious about for all of you potentially is how do you make use of older, sort of more senior research students as mentors in the group, as opposed to you doing all the training? Do you do all the training? Do you let certain kinds of things be, Do you let students do some of the training? How does that work in your group?
So I absolutely have my senior undergraduates and my graduate students as mentors for the anybody who's new coming into the group, because they need to have that at the end of this. They need to be able to mentor other people. So we have mentors upon a mile of mentors upon each other, helping each other through the system.
Yeah, I can have anywhere from one student in the laboratory like I do currently. So I'm doing all the mentoring. Once I had 9 students in the laboratory of various levels. So I was able to have that mentoring chain. Students though in my lab are oftentimes on different projects, significantly different projects. So they kind of get to build that project in their own way. And then when somebody comes in, hopefully when somebody comes in, they get to mentor that person. So.
At least in my lab at Fairfield, I do a lot of the mentoring, but oftentimes I have junior and senior students, and they do some of the mentoring as well. Usually I have a couple students in the lab at the same time when we work, so it's natural that the mentoring will happen from the other student as well, in addition to me.
I will go last. I do have students mentor each other too. Particularly lately, I have a second year graduate student, first year graduate student, and senior students, and they work in subgroups. So the first couple of semesters, they join one of the subgroups, and they learn how to do research and get equipped with it, and then they come up with their own research project.
Yeah, that's a really good question in terms of like at what level do you let students choose their own directions in the research, and to what extent do you allow students to, you know, kind of get something and run with it? I'm always sort of I'm never quite sure how much to allow them to do that, but in general, when I've done that, it's been successful.
Yeah, so lately I have been teaching upper level courses in organic chemistry. It's 3,000 level course, and advanced in organic, and graduate in organic, now graduate organometallic. So they're pretty mature with respect to allowing them to choose a project. We also have chemistry problems. It's a independent study course. It's required for our degree. So for that independent study course, after they're trained, after they interned, I ask them to pick a topic that's related to what we're doing. I try to have them as independent as possible later on, but I definitely miss having freshmen in the classroom, but I have not been teaching any Gen Chem courses. Very difficult when you don't get to know them, to recruit them to the lab. But with the senior student and the graduate students, it has been going pretty well lately.
That's great. That's great.
But yeah, I also get them started reading the literature. Our previous paper, they download the programs. Most of them are free or trial version. They figure it out. If they can't, they'll ask one of us. But it's basically having them, giving an opportunity to train themselves reading the literature and learning the software so that they can actually do research with us. I try to upload as many training videos as possible, the tutorials on our group website, so they're not alone in the learning process. But without learning the tools, without learning the literature, it's really very difficult to get them started on any research project.
So you're making actual like tutorial videos for them. Yeah, was that very time consuming?
No, not at all.
And
not at all.
Them.
Yeah, and my students do that too. It's very helpful. And also, whenever we meet in the subgroups and the group meetings, they want to record. And after the pandemic, we're recording everything anyways. So they really ask permission to record it. Whenever I'm explaining something, they're like, could you please record this and then post it on. So we have several sites that we post our group materials. We use Microsoft Teams, we use OneDrive, and we have plenty of cloud space. So they have been very good at it. They actually ask for permission to record it, and if they don't understand anything, I just explained once and they circulate it.
That's awesome. It's a great idea. One of the benefits of the pandemic.
Yeah, absolutely.
Well, thank you very much. Oh, go ahead.
Yeah, since we do computational chemistry, so it's mostly them learning how to do it on their own time. But if it's a lab work, obviously it's very difficult. I would be in the lab with them all the time, just keep an eye on, and particularly the freshmen students early in my career. But now, since it's computational, we also have a staff member joined our group from Texas Advanced Computer Center. So she joins our group meetings and she works with the students one-on-one. So it's amazing to have that kind of support where the students can go to for technical questions as well. So I just mentor them with respect to research.
That's terrific. Having done some computer stuff over the summer, I realized the importance of that kind of technical help, which we didn't always have. But
yes, absolutely.
Yeah, no, so I think for us, our students come in with a very different background. So I teach a class, an introduction to nanoscience that first year students can take, and we go through how to read papers, how to go through the landmark papers. They have to be able to present on those. And then we have an undergraduate and a graduate version of Introduction to Research, where we go through how to read papers, how to write papers, and they actually come out of those writing proposals for research projects that they would end up doing, sort of along the lines of like a fellowship. And then, so our undergrads come in a few different ways. So they can come in and take like an independent study class where they're getting some credit for this. And there we need to carve out specific deliverables and what they're going to do to pass this thing. We have a required senior thesis project where, again, that's 5 credits and they have to propose what they're going to do and what the deliverables are going to be. And then we have students who just volunteer sort of at a younger level. But I teach those classes on Intro to Research to all of the students, not just the inorganic ones.
wow, that's nice having that sort of built into the curriculum.
Yeah.
So is that worth like the normal amount of a normal course, or is that like a fractional of a regular class?
So it's a 1 credit course that they take in the fall. So we call it 395, and the 495 is the required 5 credit senior thesis research. And
Gotcha.
So you need it as a prereq for the other one.
Gotcha.
But it ends up working out very well and getting them to work in small groups, going through papers, and then I think it's also it's really powerful to them to show them that like some of the stuff in the literature from even 20 years ago still isn't in the books that they're reading, and so they have to be able to do this.
Yeah, so important. All right. Well, thank you all, and we will end up this, and there'll be more in the future. So thank you again.
Thank you.
Thank you, everyone.
Thank you.